matrix equations. This is page 16 of our note packet, our matrix note packet. A matrix equation is an equation in which a variable stands for a matrix. You solve a matrix equation the same way you solve regular equations. So for example, an example of a regular equation, just in case you're wondering what we're talking about there, is if we wanted to solve, my computer is really bogged down right now. Okay, so we were going to look at an example of just a regular equation of some sort. Like, what if we have something like 3 plus x equals 5? How do we solve an equation like this? What do we do to solve it? Do you remember? This is pretty simple. If it's adding, like this is a positive 3, we would just subtract the 3 from each side, right? And we would get the x equals 2. Or if we had a completely different problem, so that's one problem, so we'll call this number 1. And here's another example, number 2. What if I had something like 4x equals negative 12? How would I solve that? Well, this one has multiplication in it, so we would divide it, right? So dividing would mean our answer would be a negative 3. So there's just some regular algebraic equations where we have to solve by subtracting something or solve by dividing something. Correct? So that's the idea behind these problems here. Only these are matrices instead of just like little equation things. You don't have to write this down. This is just to kind of refresh your brain on solving just a regular algebraic equation. So we want to solve for x, and x happens to be a matrix, because we're adding a matrix to it and we're getting a matrix as an answer. So that means when we find x, we're actually finding all 4 numbers in a matrix. So to do that, this is adding a matrix. What's the opposite of adding a matrix? Subtracting it. So we would literally be subtracting the entire matrix from both sides, which would cause it to cancel out here. And our answer will come from subtracting it here. So let's go ahead and subtract corresponding elements. So 6 subtract 3 would be 3. And 3 subtract 2 would be 1. And 7 subtract 1 would be 6. And negative 1 subtract 0 would still be negative 1. So what we just found is a matrix that is being represented by x, so that when we take this matrix plus this matrix, we would get this matrix, right? And we did that by subtracting our matrix from both sides. What if it had already been a negative instead of a positive? This one was a plus, but what if it had been minus a matrix instead? What would we have done? Then we would add it to both sides, right? We always do the opposite. Okay, let's look at this scalar multiplication problem. This one has 3 times x equals this matrix. So if we want to find x, we need to get rid of 3. So in this little example we did up here, we divided both sides by 4 to get rid of the 4. Is that correct? So we could kind of do that here where we're dividing both sides by 3, except I'm going to write it a different way. Instead of dividing by 3, I'm going to multiply by 1/3. And that will accomplish the same thing. So instead of divide 3, multiply by 1/3. And that's going to do the same thing as divide by 3. So what I do to one side, I have to do to the other side. So that's multiply by 3 on both sides. So I'm multiplying by 1/3 here, and I'm also going to multiply by 1/3 here. All right. My computer is still lagging, even though I turned off my video. Very weird. Okay, so I'm multiplying by 1/3. 1/3 times 3 cancels out that 3 because 3/3 equals 1, correct? So if we have 3/3 x, we actually just have 1x. So 3/3 x is just the same as x. So then we take this 1/3 and multiply it through each of these numbers in this matrix. So like 4 times 1/3 would be 4/3. And -9 times 1/3 would be -9/3. But when we have a number that's divisible by 3, we should actually divide it. Does 9 divide by 3? It does, 3 times, right? So -9 divided by 3, or multiplied by 1/3, it's the same thing. -9 divided by 3 is a -3. So that -9/3 actually reduces to -3. Then next we have 0 times 1/3. What happens anytime we multiply by 0? 0. And then we have 2 times 1/3, which we can't divide that out, so we just leave it as 2/3. And then we have 3 times 1/3. What just happened over here when we did 3 times 1/3? 3 times 1/3 turned into a 1 because we get 3 divided by 3, which is 1. And then we have -6 times 1/3. So -6 times 1 divided by 3, so that would be -2. So -6 divided by 3, or -6 times 1/3 would be -2. And that is our answer for that problem. So far we've seen 2 different matrix equations, one where we subtracted an adding matrix from both sides, and one where we had an extra 3 in there, so we had to divide by 3, but instead of dividing by 3, we multiplied by 1/3. Okay, now we're going to see the important problem that I really want you to understand today. This says solve using an augmented matrix, but I crossed off augmented and I changed this to matrix equation. This is what we started to look at in our previous video on our previous page. So again, instead of making that augmented matrix, it's very similar. I still just do the coefficients, but I'm actually going to do several matrices instead. So the coefficient next to x is 1. And the coefficient next to -y is -1. The coefficient next to -2z is -2. And the coefficient next to 3x is 3. And the coefficient of 2y is 2. Uh-oh, our last number needs to be a z. There is no z. What do we put there? 0. Good. And then on the third equation, the coefficient of -4x is -4. And the coefficient of y is 1. And the coefficient of -z is -1. So instead of making that an augmented matrix with these numbers at the end, I'm just going to have a separate coefficient matrix times a variable matrix. Now this is where, I talked about this before, we could just use an x here, but I'm actually going to call this matrix, instead of calling it matrix x, I'm just going to call it a matrix with elements x, y, and z in it. Because this will allow us to solve for x, y, and z. That's our point here, is to solve for a missing matrix, which is what we have right here. Okay, and then this is going to equal our constant matrix, which contains -6, 25, and 12. So this matrix equation is a little bit like the problem we just did, except instead of one number times our missing matrix to equal another matrix, we have a whole matrix times our missing matrix to equal another matrix. So on this problem, we divided by 3, or multiplied by 1/3, but on this one, that would mean we would be dividing an entire matrix, and we don't divide matrices. Instead, we use inverses. So instead of dividing this matrix from both sides, we are going to use an inverse matrix. So I'm going to write that down, what I just said. Use an inverse matrix, which we learned about last week. We don't really call it division, but basically that's what we're doing, is we're trying to divide matrices. Okay, so in order to solve for x, y, z, we are going to use a matrix calculator. We're going to find the inverse of our coefficient matrix. So in case you've forgotten how to do that, we type in the matrix itself, and then we take that matrix to the -1 power, and that finds the inverse for us. So that coefficient matrix to the -1 power, that's the inverse. And then we multiply that matrix times our constants, -6, 25, and 12. Okay, so in order to do this problem, we need to use a matrix calculator, unless you want to multiply it by hand. But you can't multiply it by hand until you know what the inverse is, and we don't know how to find an inverse of a 3 by 3 matrix by hand. So we're going to go to Desmos.com, and here we are. When we first go to Desmos.com, here's what it looks like, and we want to go to Math Tools and choose Matrix Calculator. That brings us in here. I'm going to make it a little bit smaller so I have more room. I don't actually type in the XYZ stuff. What I'm typing in is all of this other stuff. So I'm going to hit the button that says New Matrix. I want my matrix to be a 3 by 3. I'm going to type in 1, -1, -2, 3, 2, 0. This is what you did on your assignment last time. -4, 1, -4, nope, -1, I typed it wrong. Always double check to make sure you typed it in right. Gonna hit enter. Now I'm going to type in a new matrix, and I'm going to call this one matrix B, and I'm going to make sure it's 3 rows but only 1 column. So for that one, I'm typing in -6, +25, +12. So I have typed in this matrix right here. It turned out to be a matrix A. And I've typed in this matrix right here, which is turning out to be matrix B. Hit enter on that one so that those matrices are stored in my matrix calculator. Now I'm going to type in A to represent this matrix A. I'm going to hit the -1 power so that I turn that into the inverse. That's how I divide. And then I'm going to hit B for multiplying by matrix B. And that gives me this answer right here, which you could totally just write down rounded versions of the decimals. That would be fine. Or you can change it to fractions. So this allows us to find our answers. And I already have this here from yesterday that I pasted from Desmos. So here are the answers that I got from Desmos. That means that this is what x equals, and this is what y equals, and this is what z equals, because we solved this matrix equation and we found this matrix represented by elements x, y, and z.